All right, so this is going to be 8.1 arc length. You get to far more detail about arc length once you go into multivariable calculus, which is the next class after this. But just a brief introduction of it. And actually, all of Chapter 8, the three sections that we're going to be dealing with, is a precursor to multivariable calculus. Just gives you a little snippet of what you guys can be dealing with in that class as well. Okay, so we're not going to go too much in depth. You see it far more in detail in the next class itself. Okay. All right, so arc length. So what I mean by arc length itself is, the measure of the entire arc or measure of the entire curve across. So, right, so when you think back to geometry, when we have a circle, we could find the arc length of, let's say, from point A to point B here. Right, remember arc length is like if I just cut it, and what's the length of that little arc itself. It's here when it comes to curves. So now we want to figure out, okay, well, given this type of curve here, let's say from here to here, what's the length of this curve? Again, if I just stretch this all out, what's the length it's going to be itself, okay? And that's what we're going to be going into this concept when it comes to it. And this is actually a pretty interesting concept when it comes to it. What we're going to do is, well, we're going to do point by point. So let's say from here to here, there to there, there to there, and just put, points throughout the portion. And what we want to do is we're going to connect every two points together. In other words, if we do that, we will now have a line. So a line connecting each individual portion. And you notice, some of them are good, some of them are bad, right? Some go a little below, some are a little high. But essentially, that's how we're going to be estimating the arc length of it. We're going to find the distance between each individual line from point A to point B. These are, individual points between A and B. Right, like for instance, x1, x2, and so forth. So we're going to find the distance between 2 points and add them all up itself. Okay? Or in other words, find the sum of all the distances between these portions, or the lengths of these lines, and then that's going to be our estimation of arc length itself. Okay? So since we're talking about the distance formula, you can kind of understand why our equation right here for arc length is given that f prime is continuous, so the derivative is continuous on AB. Then the length of the curve y equals fx from A to B is equal to the integral of square root of 1 plus f prime of x squared, right? And this kind of makes sense because, right, this is the change of y. So this is a change of the slope happening when it comes to, so remember our radial distance formula is square root of x1 or x2 minus x1 squared plus y2 minus y1 squared, right? So essentially, the x values aren't going anywhere. It's actually just 1 squared. The distance is always going to be 1. And what's changing here is just to change the y's. Okay? And that's why we go with the derivative, because that's the change of y's itself, right? The slope of what's happening. Okay? Now, these are going to be pretty difficult. The setup is going to be frustrating, but the actual integration will actually be pretty nice because a lot of stuff actually cancels, and you'll see that in a little bit. And that's kind of what you want to deal with when these type of questions is it's going to look like a horrible integral, but all you have to do is really simplify and try to get rid of that square root, and then it becomes kind of nice integration to deal with. Okay, so let's try an example so you can see how this will work out. Okay, so find the arc length of the curve 36y squared is equal to x squared minus 4 to the third power between the values of 0 and 1. Okay. So first thing we're going to do is solve for y. So right, just dividing 36 and taking the square root, we get y is equal to this, right? Okay. And I'm just going to rewrite it real quick. Like we know what the square root of 36 is, it's just 1/6. And I'm just going to put this into its exponent form. So this is 3/2 power, right? And the reason why I do this is because notice, in order to find the arc length and take this integral, we have to find f prime. So in other words, in this case, we have to find what y prime is. So just a quick reminder, right? This is going to be the chain rule, derivative of the inside times the derivative of the outside. So this is going to be 1/6 times I'll do the outside. Derivative of the outside is going to be 3/2 itself raised to the -1, so just 1/2 power, times derivative of the inside, which is just going to be 2x. So if we just, kind of clean this up, notice the 2 and this 2 cancel, which is kind of nice, right? And this 3 and this 6 cancel, so you just get half. So I'll just put this as a half here. And this x is on the outside, then times all of this on the inside. And there we go. Just make it a little nicer to look at. Okay. All right, now that we have that, now let's try our integration and see how that's going to go. So the length of this curve is going to be the integral from 0 to 1 of the square root of 1 plus all of this squared. Like that. Okay. All right, so you may think, oh boy, but actually, well, look at this, right? Remember, if I distribute this, I'm going to have x squared over 4. And over here, these actually cancel. So what I'm left over with inside the square root is x squared times x squared minus 4 to the third power divided by 4. Okay. So that's what we have so far there. Okay. Oh, sorry, 1/2. This is now 1. They cancel out. There we go. That's what I want. Perfect. Right. So 1/2 times 2 gives you the 1 itself. So now we're just going to distribute here and for this out to make it a little nicer to look at again. So if I try to put everything together, this is going to be 4 over 4 plus all of this. So if I distribute this, it gives you x to the 4th minus 4x squared. And then plug in this all stuff together. And believe it or not, that actually factors kind of nicely. Okay. So let me get another sheet of paper so you can see. So the top actually factors to a nice x squared minus 2 squared, and that's over 4. Right, just simply factoring rules, right? If you use x method or AC method. And now notice, look what happens to the square root. Everything cancels, right? That cancels with that. Square root of 4 is 2, so this ends up being the integral of 0 to 1 of x squared minus 2 all over 2 dx, which is far easier to take the integral of when it comes to it. Okay. So again, make it look a little nicer because we'll have 1/2 integral of just x squared minus 2 dx. And notice, oh, so much easier, right? So take the integral, we're going to have here x to the 3rd over 3 minus 2x, right? Evaluated at 0, 1 times the 1/2. Okay. And then we just plug in, right? So it's going to be 1/2. So if I plug in 1, I get 1/3 minus 2. Minus, and I plug in 0, I get 0 out, right, when it comes to it. Oh. Yeah, that's right. And now we just subtract and multiply. So in this case, we get, what do we get? 1/2. Okay. And this ends up being over here, 1/3 minus 2, I think that's what, 1 and negative 1 and 2/3. Right? Or again, if you're not sure what I did that there, same thing as negative 5/3, right, when it comes to it. Okay. And then multiplying by the half gives you negative 5/6. Now, this really makes sense, right? How can the length of the arc be negative? Right? That doesn't really make sense there. Well, that's the reason why, because remember, if we take the square root of a negative, well, that means we have to make it all positive. So essentially, we're just taking the absolute value of all this. So if we go back over here, we actually have to do all of this. Hence the reason why this is the absolute value. So now, if we take the absolute value of this, this is now 5/6. So that makes more sense itself. Okay. And hopefully that makes sense, right? Because if you take the square root of a square, going back to algebra, right, you can have the positive or the negative. And we're always going to have the positive because, again, arc length can, length of arcs cannot be a negative, right? It's, again, we're just like stretching it out and actually seeing the distance between one point to the other point, right, on a number line. Okay. So that's our first example. And again, it's pretty lengthy, but hopefully you notice, right, it's a lot of just manipulation, And the actual integral itself, it wasn't too bad to deal with, right? It's a simple just power rule at that point, and just plugging and chugging when it came to it. Okay. So let's try another one down here so you can see as well. So this may be a bad one. Who knows, right? I just have fun sometimes. So find the arc length of the curve x is equal to y to the fourth over 8 plus 1 over y squared from 1 to 2. Now, we're going to talk about, when it was x, and you may think, okay, I really don't want to solve for y in this case. It's a horrible mess, right? So the same thing applies for arc length when it comes to given a value with respect to x. So I can say this is, or if we go, instead of going from this way, we go the other way, going up and down with respect to the y variable. The same thing as the integral from c to d of the square root of 1 plus g prime of y squared, dy. So now everything's with respect to y instead of x. Okay. So whenever you have a curve, you could solve for y, go right ahead and do it, makes it easier. But when you can't solve for y, or they already give it to you as the curve with respect to y, you're just going to use this integration step. So same exact equation. Now we're just going to solve with respect to y instead of respect to x. Okay. So step one's already done, right? We already solved for x, which is good though. So now we're just going to find the derivative, or dx dy in this case. So for this one, it's just going to be derivative, so it'll be 4 over 8 y to the third. And this one, again, I always like to do this. So this is technically 1/4 y to the negative 2, right? So if I take the derivative, this is now negative 2/4 y to the negative third power. And just simplifying this gives us, this is 1/2. This is also 1/2, like that. Okay. So if we put stuff together, right, this is, when it comes to this, is technically y to the third minus negative y to the third over 2, right, when it comes to it. Now, we actually don't want it to look like this, believe it or not. If you try to put this in, it gets horrible. So I'm just going to give you guys this hint, why I did this, is I'm going to change this up. So if I'm going to go back over here, so, that's probably the way you guys want to go. But if I bring this down here and just add them all together, so in other words, have y to the third over 2 minus 1 over 2 y to the third, right? It's technically what that is. And if I want to put these together, therefore I have to multiply this side by